Hello everyone. So now we'll begin with this class from whatever we had discussed yesterday. So we'll move forward with the small recapitulation of the same thing. So we had discussed these two cases. Maybe I can bring these completely to the screen and then we can discuss. Yeah, so this is the first case, that is when we have the line parallel to the vertical plane and inclined to the horizontal plane. Okay, and for this what we have is please keep yourself muted. What you have is this front view gives the true length and also the true inclination with the horizontal plane, right? Top view of course becomes a reduced length. Then we had considered the second case. Okay, so for this the line is parallel to the horizontal plane and is inclined to the vertical plane. So for this we get the true length in the top view and the actual inclination of the line with the vertical plane also is observed in the top view. The front view gives us the reduced length. Front view is a reduced length. It is not the same length. So these two things we have. Thereafter what we had considered that if the line is inclined to both the planes, right, then these conditions will actually not be available with us. By these conditions what I mean is if the line is inclined with both the planes, then we will not have a situation where we have the true length of the line available and the true inclination available, as is available here in the front view and here in the top. So these things will not be available when the line is inclined with both the planes, right? Also, further we had discussed that suppose if I keep in this figure this capital A fixed at its location and I also keep this theta constant and then I try to move this B, then the motion is this motion, how will it look like in the front view and top view if we try to visualize that? Then the top view will have a tendency that A will remain fixed, small a will remain fixed, small b will actually rotate on a circular arc about A, right? Also, then we had considered that this B dash will have a path which will be straight line parallel to xy. Okay, this is when A is kept fixed and theta kept constant, and then B we try to move. So the how the front varies that we discussed. The same will happen here if this A is kept fixed, phi is kept constant, and this then B is moved, then this B dash in the front view will move on a circular path about A dash, and this small b in the top view will move along a parallel line which is parallel to this xy line. Okay, so for this situation B will move like this. Okay, and B dash will actually rotate about A dash. So these things were discussed last class also. Yeah, now let us just again read out these things. So when this line is parallel to vertical plane, top view is parallel to xy line. This is an additional thing what we observe. And when the line is parallel to the horizontal plane, the front view is parallel to the xy line. That's what we have. So line here is parallel to horizontal plane. Front view then is parallel to xy line. Although it is reduced length, not the true length, but it is parallel to xy line. Likewise, when this line is parallel to the vertical plane, then top view is parallel to the Okay. So here we have these many things, like when the line is parallel to vertical plane, one thing is true length of the line is available in the front view. True inclination with the horizontal plane is also available in the front view, and top view is parallel to the XY line. Fine. When the line is parallel to the horizontal plane, top view gives true length, true inclination with the vertical plane is available in the top view, and the front view is parallel to the XY line. So these things we need to keep in mind when we proceed further to obtain the projections for the line which is inclined to both the reference planes, that is vertical plane as well as the horizontal plane. These problems I discussed last class. Yeah. So these features also were discussed last class when the line will be inclined with both the planes, right? Then what will happen? You will have neither the front view giving the true length nor the top view giving the true length, right? Nor this inclination of front view with the XY line give us any true inclination, nor this inclination of top view with uh, XY line gives us any true inclination. So this alpha and beta we call as the apparent inclinations, because these are not the true inclinations of the line with the uh, horizontal and vertical planes. So different symbols we are using. Okay. Now we consider this case where we have to obtain projections for the line which is inclined to both the reference planes, and this is the information say available to us, the length of the line, and then position of one endpoint where it is located, and the inclinations of the lines with horizontal plane and vertical plane. So then here we'll see how do we proceed. So this gives us the case line AB inclined to both the planes, right? None of the inclinations true inclinations. So now how do we proceed? That is the question. Like earlier what we used to do, we used to locate this A dash A, right? Thereafter we simply considered, okay, line is parallel to one of the whichever plane. So whatever is the view in that plane, if the line is parallel to vertical plane, then the view in the vertical plane will be front view. So front view gives us the true length and true inclination of the line with the horizontal plane. So that we used and located the B dash. But here we cannot do it because front view is the reduced length. So now what we'll have to do is we'll have to actually consider the facts whatever we obtained when we assumed the line to be when we had the case of line to be parallel to vertical plane or horizontal plane. So to proceed further beyond this point, we actually will consider those cases hypothetically for this thing. So here what is shown that this line is inclined with the both the reference planes, and this is the front view, this is the top view. And now what we are considering is that how do we finally arrive to this? Well, when we have to draw, then how we successfully draw these final views. So what effectively now we have to do is that we initially assume that the line is parallel to the vertical plane. If the line is assumed parallel to the vertical plane, then we'll be having that case that uh, true length of the line will be visible in front view, and true inclination of the line with horizontal plane will also be available in the front view. Okay, and likewise when it is assumed parallel to horizontal plane, we'll have the true length available in the top view and inclination with the vertical plane available in the top view. So we begin with these things. Okay, so we suppose we have been given location of the one endpoint, right? So I'm repeating, we have been given location of one endpoint, we have been given length of the line, and we have been given the actual inclinations of the line with horizontal and vertical plane. Three things given. So first of all, of course, if the location of one endpoint is given, that can actually be located. So that's what is depicted here. With the given location, you draw A dash and A, right? Thereafter, we have to sequentially assume the line to be parallel to vertical plane and parallel to horizontal plane. So here, this line, that is from this step, the next step is obtained by assuming the line parallel to vertical plane. So if line is parallel to vertical plane, inclination with the horizontal plane, whatever is available to us, the same will be visible in front view. Okay, and true length also will be visible in the front view. So we take this inclination with horizontal plane, we take the length of the line, and we can look at B1 dash. Fine. Now corresponding to this, we can obtain the top view. Okay. Now before that, again, this represents the case when this line is assumed parallel to the horizontal plane. Then again the same exercise is done, and this theta inclination considered, true length of the line considered, and B2 located. Okay, so these two, that is this A dash B1 dash and A B2, these are not corresponding front view and top view, right? Both are for different situations. So this is when this front view is valid when line is parallel to the vertical plane. This top view is valid when the line is parallel to the horizontal plane. And that is why the end point we have given different names. We have not given same name for both. Here we are calling this B1 dash, and here this one being called B2, because these are not corresponding diagrams, right? Both are depicting
So,
different.
sir, sorry to interrupt you. So, can we conclude that either we can get the original lengths or the original angles
No, it
for
is
this
not
case?
so. No, it is not so. See, I told you, if the line is parallel to the vertical plane, then front view gives you the true inclination and it gives you the true length, right? True inclination with the horizontal plane is visible in vertical plane, okay, or in the front view. Likewise, when the line is parallel to the horizontal plane, its true length is visible in the top view, and also its true inclination with the vertical plane is visible in the top view. Okay, so yeah, so again, let us come back to this diagram. So what we have done is, first of all, we were given the position of uh, one end point, so we have drawn A dash and A. Okay, then thereafter we first assumed it to be parallel to the vertical plane. So for that case, we have used this theta and the true length and obtained B1 dash. Then we assumed it to be parallel to the horizontal plane, and we used this phi and true length and obtained B2. Okay. Next, now what we can do is we can consider their corresponding what do you call uh, other views. So like for this case, here we have the top view available to us when we have the line parallel to the horizontal plane. So corresponding to this, what is the front view that if we have to obtain, then we can make use of the fact that if the line is parallel to the horizontal plane, right? If the line is parallel to the horizontal plane, then its front view will be parallel to the XY line. That is what we discussed in the beginning of this lecture, right? So if the line is parallel to horizontal plane, the front view of the line is parallel to the XY line. So if I draw a projector from here, okay, if we draw a projector from B2, then it will intersect this line drawn parallel to the XY from A dash. So this will give us B2 dash. This will give us B2 dash, the current location of pointer. right? So this actually is what? This is the front view corresponding to this position when the line is assumed parallel to the XY. Okay, so say this is what we obtain, right? Now here, let us recall one thing. When we get considered that this A dash B1 dash what has been drawn, that is with the consideration that line is parallel to the vertical plane. Okay. Now let us recall at this point what we discussed initially. Let's suppose if we have the line and its a point is kept fixed and theta kept constant, and then in this uh, in wherever the line is situated, if we try to move the point B, okay, by keeping this theta constant, then what we had discussed that this B dash, whatever B dash we have for particular value of theta, it will move along a line parallel to XY, right? It will move along a line parallel to XY. This is coming from the fact that as long as the inclination of the line with the horizontal plane remains same. ये तो अच्छी बात है ना, इसमें सैड क्यों हो रहा है? सुबह पापा को keep your microphone switched off. Don't let it remain on. Okay, so now you see this uh, theta, as long as the theta remains constant, right? Then the distance of B from the horizontal plane will remain same. Okay, A dash at a particular position, theta constant. Then wherever we might locate this line, right? Wherever we might locate it in the 3D diagram, wherever it is located, distance of the other end point from the horizontal plane will not change. Okay. So considering that, now suppose this in one position, parallel to vertical plane, we have drawn it like this. If the line is not parallel to vertical plane, but the angle with the horizontal plane is still theta, then this B will assume some position along this line. Why? Because its distance from the horizontal plane is not getting altered. So obviously then in this front view, distance of this from the XY line will not get altered. It will remain whatever distance we are having for this position. Okay. So this is one fact. As long as line is inclined at angle theta, then whatever distance of B1 dash in this diagram we have obtained, right? Whatever distance of this B1 dash from XY we have obtained in this diagram, it will not get altered, right? Location of B1 dash, if it is to be changed, it will be along this line only. One thing. Second thing is, as long as the inclination of the line is phi with the vertical plane, what is visible in the topic, as long as the inclination of line is phi with the vertical plane, right? The length of the front view, whatever is available here, A dash, B2 dash, this will not get altered. It will remain this much only. Okay. As long as inclination of the line is phi with the vertical plane, then length of the front view will be this much only. Only its orientation may vary. If we keep the same inclination and place the line in different orientations, A we keep fixed, and then we change the orientation of the line, then this length will not get altered. Only it may move around this A dash. This B2 dash may move around this A dash, but this length will not get altered. So now what we can do is we can merge these two facts together, right? We have obtained this diagram and this diagram, these two diagrams, this diagram and this diagram, we have obtained considering two different cases. One when it is parallel to the vertical plane, this one when it is parallel to the horizontal plane. Fine. With this condition, we get the length of the front view. Okay. when line is inclined with an angle phi. One thing. And with this condition, we get the distance of B1 dash from XY when the line is inclined at theta inclination. Okay. So if we merge both the conditions, then what we can do is this B2 dash can be brought to this level. That is done in the next step. Okay. This B2 dash is brought to the level of this B1 dash. So this actually will be the location for the actual front view. Okay. That means this A dash B dash will be corresponding to the line which will actually have both the inclinations, theta with the horizontal plane and phi with the vertical plane. Okay, so this view A dash B dash will actually fulfill both the conditions. Okay, likewise the opposite now can be done. So we can have a corresponding length of the top view obtained here from A dash to B1 dash. We have the true length and we have the inclination theta with the horizontal plane. Corresponding to this, if we obtain the top view, that is drawing a line parallel to the XY line. That's what we have seen earlier, right? If the line is parallel to vertical plane, here we get true length, true inclination, and the top view remains parallel to the XY line. So using this, we get this B1. So this gives us the length of the top view. For the case, length of the top view, for this is case when line is inclined theta degree to the horizontal plane. Now if we want to impose the other condition also, that is the line is also inclined 5 degrees to the vertical plane, then what we have to do, again use this length and use the distance whatever is shown by this B2 from the XY line. So again both the conditions are to be superimposed. So what we do is this AB1 can be brought after rotating it and brought to this level. Okay. So this will actually be giving us the location of top view. Okay. Here one more thing let me mention. This thing what we did, we brought this dash to this location B1 parallel to XY. Then this rotated and brought to locate the final top view of point B. Okay. This can be done by considering the fact that this B dash and this B will be on the same projector. So we can draw a vertical line from this B dash and bring it down up to here. So for the second step, this can also be done. Okay. And this AB actually then locates the top view. Okay. So what we have done here is we were given position of one endpoint, length of the line, and inclinations of the line with the two reference planes, horizontal plane as well as the vertical plane. And then we try to obtain its projections, front view and top view. Okay. And for that, what we have done, we initially assumed it to be parallel to the uh, vertical plane. So there we obtained two things. I think the next slide will be better. Yeah, and then I'll explain this again. So here in this diagram, you can see theta actually is the true inclination of the line with the horizontal plane, and alpha is the apparent inclination which will be available in the front view. Likewise, phi is the inclination of the line with the vertical plane, and beta gives the apparent inclination what we actually obtain when the line is inclined with both the reference planes. Okay. Yes, so probably this diagram has the details whatever we wanted to discuss, right? So again, let me repeat. So what we are actually discussing over here is one location of one endpoint given to us, A dash A, number one. Then apart from that, we have true length of the line available to us, and we have true inclinations of the line with both the reference planes available to us. Okay, so theta gives the inclination of the line with the horizontal plane, phi gives the inclination of the line with the vertical plane. Fine. With this given information, what we are trying to do is we are obtaining front view and top view as shown by this A dash and B dash. This is the final front view, small a, small b. This is the final top view. So this is what we have to obtain finally. For this, what we are doing is we first of all are assuming the line to be parallel to the vertical plane. Okay, so that allows us to draw A dash B1 dash. That is, we use the true length of the line, we use theta, and we locate B1 dash. Okay, with the help of this A dash B1 dash, with this condition when the line is assumed parallel to the vertical plane, we are able to obtain two things. Number one, distance of B1 dash from XY. This is what we obtain with this step, right? And we know if for the final projections of the line, if the inclination of line is theta with the horizontal plane, then B1 dash will have this much distance only from the XY line. So from here we get to know how much away B1 dash or B dash will be from the XY line. That is one information we get from the first step, assuming line parallel to vertical plane. Second information we get is when we project it and draw a line parallel from this A, then we get the reduced length for the top view. That is, when the line is inclined theta at an angle theta with the horizontal plane, what will be the length of the top view that we get from this step again. Okay. So that is these are the two informations obtained. Thereafter, what we do, we assume the line parallel to the horizontal plane and then we draw this AB2 using this phi inclination with the vertical plane and the true length. We obtain AB2. Okay. Now again, two informations become available to us. One is how much distance this B2 will have from XY line. But as long as line is inclined with an angle phi with the vertical plane, B2 will only have this much distance. This we get to know. Also corresponding to this, if we obtain the front view, that will be parallel to XY line, A dash, B2 dash. So this gives us the length of the front view. Length of the front will be this much only as long as line is inclined with an angle phi to the vertical plane. Okay. So with these two things, what we obtained, length of front view, length of top view, and distance of B1 dash from XY line or B dash from XY line, and distance of this B from the XY line. Okay. So hereafter we merge the conditions. We know that length of front view will be only A dash B2 dash as long as the line is inclined at angle phi with the vertical plane. So this length of the front view we make use of, and since B dash anyways will maintain this much distance as long as inclination is theta with the horizontal plane, right? Please switch off the mic, please. See, don't you do this rubbish again and again. Okay. So what we are discussing is we have to merge these two situations, right? So we know that length of the front view will be this much only, this A dash to B2 dash. This much only will be the length of the front view as long as the line is inclined with an angle phi. Also we know that B dash will maintain distance from here to here, this much distance from XY, as long as the inclination is theta. So if we bring this A dash B2 dash at this level, right, then both the conditions are merged together. Okay, so this A dash B dash then represents the front view for the case when the line is inclined with angle theta with the horizontal plane and angle phi with the vertical plane. So both the conditions are merged with this. Likewise, when we bring this AB1 to this location, then again we merge both the conditions and obtain the final top view. Explanation just goes the same way, whatever we have discussed here. Length of the top view is this much, as long as inclination of the line is theta with the horizontal plane, and distance of B from the XY line will be here to here, this much, as long as the inclination of line is phi with the vertical plane. So we bring it over here, then both the conditions are merged and we get this AB. And as I mentioned again, B dash and B again will be on the same projector. And what we have here is this alpha. Now front view is making an angle alpha with the XY line, and that is apparent inclination, right? Not the true inclination of the line with the horizontal plane. Likewise, we have this angle beta, which again is the apparent inclination of the top view, right? And not the true inclination of the line with the vertical plane. Yes, so we could proceed with one example, and before that, if you want to ask some questions, you can probably you can write also if you want the questions. Yes, okay. How we got alpha and how we got beta? Some people are asking like that. Hmm? See, we got it by once we obtained the final position of B dash here, say, and or B here. As we obtain this, we join B dash and A dash and we get the front view. So this angle of front view with the XY line, that is being referred as alpha. Likewise, angle of top view with the XY line is being referred as beta. So whenever you have a line which will be parallel to the vertical plane, then theta and alpha will be equal for the projections. But if the line is inclined to both the planes, then theta will be actually the true inclination of line with the horizontal plane, while the angle of front view with the XY line will be alpha, and that is also referred as apparent inclination. One more thing, you don't need to actually calculate things most of the times in this course. You will have to draw and obtain. If you draw it properly, you will obtain the correct answers. Okay. Yes, so somebody wrote where the idea is to obtain the projections. Yes, very true. What we are trying to do is we are trying to obtain the projections of a line which is inclined with both the planes, right? Last class, whatever we had discussed were projections of the lines when it was parallel to one of the planes, right? Now we are considering that it is inclined to both the planes, and for that, how do we obtain it? So I guess we can proceed with the example, and you can try to do this. Okay, you want me to repeat it? I think I'll try to move at faster pace. What I'll do is I'll bring back the earlier slide, whatever we had discussed last time. I mean yesterday, the same I'll just try to repeat a little from the previous slide, and then yeah. So let us have a look at this screen again, and Please try to visualize along with me. It's difficult. I don't have everything with some video available with me. Yeah. So see, first of all, let us have a closer look at these simple cases. Number one thing, when this is line is parallel to the vertical plane, then what do you have? You have this front view giving the true length and true inclination with the horizontal plane. Also, you have a reduced length of the top view which is parallel to xy. Okay, so these things we will have to make use of later on. Top view is parallel to xy when line is parallel to vertical plane. Okay, that is one thing. And also this theta and theta is the inclination with the what do you call, horizontal plane, and this true length is given by the front view. Now next what I was mentioning is this panel is not going above. Yeah, now it's fine. Yeah. So what I was actually mentioning apart from this is, say if we keep this theta same, location of this capital A same, and then we move B, then distance of this B dash, I mean then correspondingly suppose I move this B and try to consider what happens to front view. So this B dash will maintain the same distance from XY, whatever is available here, right? As long as this angle is theta and the length is capital A, capital B. Okay, so that is one thing. So that essentially means if I change this position, right now the line is parallel to vertical plane. I move this B keeping theta constant and A fixed such that now line is not remaining parallel to vertical plane, rather it is having some inclination. I move this around. Okay, then what will happen? This length will get varied, the location of B dash will get varied, but its distance from XY will remain same. Okay, so this is one thing what we are using in the next slide. Okay, this is one fact, that B dash will continue to move along a line parallel to XY as long as theta will be same. Okay, and the length of the top view whatever we have got here. Okay, if we rotate this B, sorry, if we move this B keeping theta and A being fixed, theta being constant, then what will happen? The length of the top view will not get altered. Okay, this B will move about A some position as we make any changes to position of B, but this length does not get altered. So this is what we are making use of to obtain the final projections when the line is actually inclined with both the reference planes. Okay, this is what we are trying to make use of later on. And the same set of facts is actually occurring for this diagram also. That is, as long as this phi is kept fixed and position of A is fixed here, then distance of B from XY line will be this much only and length of the front will be this much only. So if the line is not parallel to horizontal plane, rather B is moved to some location so that it is now inclined with horizontal plane as well as vertical plane both. Then what will happen? This B will actually attain some position with the same distance from the XY. So it will be somewhere here. Okay, it will attain some position by keeping same distance from this XY. Okay, and length of this front view will not vary, but this B dash will change its position and it will be somewhere else. This distance will not vary as B dash. So these things actually we are trying to merge together to obtain the projections of a line which is inclined with both the planes. That is what we are trying to do in the next slide. Okay, so maybe we can now again have a look at this. Yeah. So here then what we have done is we are moving ahead to obtain the projections of line which is inclined to both the planes, location of its one endpoint known to us, and its length known to us. So first of all, we locate the known endpoint. Number one thing, A dash and A. Then what we do is we assume it parallel to vertical plane, draw the front view, we assume it parallel to the horizontal plane, again draw the top view. So here we draw the front view. With this, if I first of all consider we're drawing with this assumption, when we draw the distance of B dash from XY is known to us. Whatever distance in the final front view the B dash will have, that is now known to us. It will be the distance of this B1 dash from the XY. The same distance will be maintained. That is one thing known to us. Also corresponding to this position when we assumed it parallel to vertical plane. If we want to obtain the top view, so that will be parallel to XY line. So that can be obtained by bringing this B1 dash to this level. It's done. Here actually it's going opposite. Here. Okay, maybe let me go with the slide. So if I bring this B1 dash here, then I'll get the reduced length of the top view. Likewise, here what has been done, the line is assumed parallel to the horizontal plane, right? So this length is known and this distance of B2 from XY is known. So the same will be the distance of B from the XY. That is known by drawing this assumed position. Okay. Thereafter, this is brought to this level. Why? Because corresponding to the condition that when the line is assumed parallel to horizontal plane, if we want to obtain the front view, right, it will be parallel to XY. So we obtain corresponding to B2, the B2 dash here. Okay. So now what we know is one thing, B dash that will maintain this much distance from XY. That we know from the condition when we assumed it parallel to vertical plane. So this distance we obtained assuming it parallel to the vertical plane, and we got the length of the front view by assuming it parallel to the horizontal plane. Okay, now we merge both the conditions to obtain the case when the line is inclined with both the planes. So we bring this length, reduced length, at this level so that both the conditions are fulfilled. Inclination with the horizontal plane, if it is theta, then point has to be at this much along this line, that is this much distance from the XY is to be maintained. That is the condition for inclination with the horizontal plane. Inclination theta with the horizontal plane, B has to be this much away from the XY line. Second condition, if angle phi with the vertical plane, then length of the front view is this much. Both the conditions merge together when we brought it here. So this gives us the final location of B dash. So we join B dash and A dash and we obtain the front view. Okay, this is when line is inclined with theta with the horizontal plane and phi with the vertical plane. And the opposite is to be done for obtaining the top view. So we got the distance of B from the XY line with this diagram. Now the length of the top view can be obtained by bringing this B1 to this level, because corresponding to this, that B1 dash, B1 will be AB1 has to be parallel to XY. So B1 will be located over here. Okay. This represents the case when the line is parallel to vertical plane. A dash B1 dash. Corresponding A B1 is obtained here. Then again, this length will be same as long as theta is the inclination with horizontal plane. And point B has to maintain this much distance when line is inclined with angle phi with the vertical plane. So both are merged when this B1 is brought to this level. So this gives us the location of B. and as we join together we get the top view. Okay, so that is the thing, that is how we obtain these projections. Further, what I had mentioned is the inclination of front view with XY line now is not giving us the actual angle of the line with the horizontal plane. Rather, it is some other inclination. So that is referred as alpha and called apparent inclination. Likewise, the inclination of top view with the XY line now is not giving us the actual inclination of line with the vertical plane, and it is some other value beta. Okay, it is again called the apparent inclination, right? Also, yeah, so here it is say more or less how we obtained this, that is mentioned, right? And the same we have discussed also. This slide is giving you all the standard names what we have to follow while proceeding with this course. And as I had mentioned, see, if all of us use different names, then it is difficult to uh, understand what one has drawn. So that is why we'll follow all these names, whatever are mentioned in this slide. So this 1, 2, 3, 4, 5, 6, 7 actually are giving you the different names. So by in particular with the standard names, what I mean is like this theta. Theta we are using to symbolize inclination of the line with the horizontal plane, right? Phi we are using to symbolize the inclination of the line with the vertical plane. Okay. Likewise, alpha is inclination of front view with the XY line. Beta is the inclination of the top view with the XY line. Okay. Also, this corresponding diagrams always try to name same. What I mean is when we assume that the line is parallel to vertical plane, we obtain front view as A dash B1 dash. That is what we obtain first. So corresponding to B1 dash, when we obtain the location in the top view, we call it B1 so that the names correspond to each other. So B1 corresponding to B1 dash. Okay. Likewise, when we draw this parallel to the horizontal plane, we draw A B2 as the top view. Corresponding to B2, we have to name this B2 dash. So this correspondence also you'll have to maintain. Now somebody may call this B2 and this B1, but if it is B2 dash, then this has to be B2. Or if this is B1, then this has to be B1 dash. Okay, so corresponding name only you have to choose. So that is another thing. Okay, fine. So then we have one or two examples beyond this. So probably we can have a brief look at this. So now here the same thing what we discussed in the previous slide, the same actually is given in this one. So line is 75 mm long. It is inclined 30 degrees and 40 degrees to HP and VP respectively. Okay. So inclinations with both the reference planes are given. And A is 12 mm above HP and 10 mm in front of VP. So location of one end point is also given. And line is in the first quadrant. So this specifically is the same case whatever we have done in the previous slide, the method. So of course we will begin with the endpoint A. We have is sufficient information to draw A dash and A at any suitable location. So we can begin with that A dash, right? 12 mm above HP. So you look at A dash and 10 mm in front of VP. So you look at A. Then line is in first quadrant. So our top view will remain below the XY and front view will remain above the XY. Okay. Then we have the inclinations. So what we will do, we'll assume the line parallel to the one of the planes first and with the parallel to the other plane second. So like that we'll proceed. So first of all, assume parallel to the vertical plane, then we obtain B1 dash. Okay, true length 75 mm, inclination 30 degrees. Consider B1 dash located. Then you assume parallel to the horizontal plane, inclination 40 degrees, and this length is 75 mm. So now you locate B2. So you know the loci of the 2 points, that how much distance B dash will be away from XY, that is known. How much distance small b will be from the XY, that is also known to us. Now we have to obtain the reduced length. So reduced length of the top view obtained for corresponding to this top view, front view will be parallel to the XY line. So B2 dash is located. Then, so this is the length of the front view available here, and of course it is available here also, but we should be using this thing, right? Then we have to bring it to this level so that both the conditions are merged together. So we get B dash. Okay, so A dash B dash completed, and then we can obtain B. Okay, so this is what we had discussed. Now consider this. So please read this and then we'll further discuss. So you have this again 75 mm long line, 45-degree inclined with VP, and front view makes 55 degrees. And A is 10 mm above HP and 15 mm in front of VP. Okay, line again is in first quadrant. Okay, and then we have to draw it first of all. So again, and A can be located. That is the first thing to do. Right, so this much can of course be done. Right, then thereafter we have the inclination of the line and the true length, right, with respect to VP. Okay, inclination with the VP will be seen in the top view when we assume the line parallel to the horizontal plane. So we assume it parallel to the horizontal plane and then we obtain this. Okay, B1, the inclination and the length we use. Fine. Corresponding front view of course now can be obtained. Okay, corresponding front view can be obtained if you draw the corresponding location of B1. It will be here on this line. Okay, this is located. Now we have the condition that front view makes 55 degrees. Line is in first quadrant. So then what we have to do is length of the front view we have obtained. Now inclination of the front view is given. This is not the inclination of line. This is the inclination of front view which is directly given. So all you have to do is you have to draw this A dash B1 dash inclined 55 degrees. That will become the front view. Okay. So you look at B dash. Now you know small b will be along this only. So now you can look at B. So this way you get the projections. Okay. Fine. What else? Yeah, and an inclination with HP is to be obtained. For that, what we need to do? We have to obtain the projection of the line when it will be parallel to the vertical plane. For line to be parallel to the vertical plane, top view will have to be parallel to XY line. So make the top view parallel to the XY line. So this thing has to be brought up to here, right? This top view is to be brought here and then move perpendicular and you will look at this. Okay. Other than that, here what has been done is a shortcut has been used. What I am saying is when the line is parallel to vertical plane, top view will be parallel to XY. So bring this B over here, right? Use your compass, bring it over here, then move vertically up. and then on this locus you will obtain b2 dash. So this will give the true length line when the line is that is the front view when the line is parallel to vertical plane. Here what has been done is true length is already known. So on this locus the true length has been directly marked and theta has been obtained. Okay. So maybe I'll stop here. I'll share some problems with you. You can solve those. Tomorrow is a very extremely busy day. So I guess tomorrow we'll not be able to have the class. Okay. So we'll have what I'll do is I'll share the problems. If you have any doubts about it, please write back to me. I'll take arrange for a separate class and I'll discuss it with you. Okay. Hmm. Okay. So I'll stop here.
Excuse me, sir.
Yeah. Hmm.
Sir, it will be very beneficial if you provide some submitted solutions from the previous batch so that we can know how we have to do it. Like on the sheet of paper, it looks different than the animations.
No, no. I'm not getting you.
Sir, I am saying that if we had a sample solution,
That you said, but I think you can refer a book if you are so much keen to know the solutions on paper. That is what I will say. Uh, and then I did not understand what you are saying that it is looking different. See, when you will solve, you will get the feeling that how the lines are to be drawn, or when you say use the compass, how does I mean how the final shapes come and so on. Mm.
okay, sir.
Mm.
So yesterday you were giving some instruction regarding the scales. Could you repeat that again?
So far we